today we are most likely going to get through 10.4 and 10.5, but that's going to be kind of weird because the other homework is 10.5, 10.6. So that's why I say try 10.5, 10.6. It should make relative good sense. But if it doesn't, don't submit it. Bring questions class tomorrow. Here's how tomorrow is going to work. We have... Hi. I appreciate your attention. We have 10.4, 5, and 6 to get through. We have 2 days, and we don't need all of both days. So we're going to do as much as we can today. Tomorrow, we're going to finish what's left and then have work time. So, you don't have to get 10, 5, 6 fully done and fully submitted tonight. I'll give you time during class tomorrow that we'll work on. Cool? Nice? Yeah? Alright, moving back this up to the TV. And please get out your 10, or did we not hand out these packets yesterday? Yeah, you got the packet. Anyone not here yesterday? Need the packet? Okay. So, please go to 10.4. We talked about the hockey player yesterday. Now, what do we know about ice, aside from that it's slippery? Yeah, Jeremiah?
It's under the basketball court, and that's Schottenstein.
Yeah, and the Schottenstein, it actually is almost always just sitting there under the basketball court. Sometimes they melt it out, like out of season, they melt it out. Andrew?
It's flat?
It's flat. So when we look at this angle, combined with this angle, what is the result? 180 degrees. So everything that we're talking about today is all about supplementary angles. Now, who can remind us, we talked about this point yesterday on the notes, who can remind us how we can remember the little saying, comparing, you gotta remember both, complementary angles and supplementary angles. You gotta remember both. Sam, because you were so nice and came to PTSA last night.
Yay!
Thank you again for that.
So, complement is like, so a complement is right, so it's like the right angle.
A compliment to compliment someone is the right thing to do.
And then the supplement is like supplements make you bigger or something?
Supplements make you bigger. If you want to get more muscles and things, you can take supplements, protein, and different things that will make you get bigger. Saw some guys at the gym that need to chill out on the supplements last night. But, all that aside, supplementary angles add up to 180. So you cannot have one supplementary angle. They have to be pairs or more. You can have like 3 angles that you say together they are supplementary, but we normally talk about this as angle pairs, and that's why today's lesson was called special angle pairs, because we're covering more than just one. But also, so today's lesson is special angle pairs. The image that I also want to show you before we dive too far in, this is what 10.5 is going to talk about, vertical angles. And that's the other set of special angle pairs. So what you see with vertical angles is this blue angle and this red angle. What relationship do those angles have with each other, the blue and the red? Honestly?
They're supplementary.
They are supplementary. What about the red and the red?
They're supplementary. Oh, no, they're...
46 compared to 46?
They're not complementary.
Nope, they're not.
They're not adjacent.
They're the same, right? 46 and 46. So if I just asked you, what do you see about the red angles? They're the same. What they're technically called, and we're going to get to this in the lesson once we get through supplementary, those are vertical. So the special angle pairs are complementary, supplementary, and then vertical. That's all you need to know for our 3 special angle pairs right now. So let's keep working through our supplementary work, and then we will get on to vertical angles. So we had these examples. Do complementary or supplementary angles have to be adjacent?
No.
No. So right here you should have noted they don't have to be adjacent. So now, we worked on this yesterday with the complements, but now we need to draw our supplements. Julian, you have your notes, right? Yeah. Sweet. So, I have 2 options here. Give me your, I'm going to do C with you, because I'm going to ask you guys to draw out the other options for A and B. To make a supplementary pair, they need to form a straight line. So I have 2 options. I can either start here and continue that straight line out and make another right angle. Sorry that my angle looks slightly not right. And then I could go this direction. So whether I do black with green or black with red doesn't matter. I have two options for supplementary pairs. And then also, green and red make vertical angles. So my green and my red are actually vertical with each other. You don't have to know that yet, but that's the cool thing that happens when I look at both supplementary pairs. Like reference 134, your blue angle up here. This 46 is a supplement to it. Or this 46 is a supplement to it. Those red angles, when I look at just those, are identical to each other and vertical. So draw both other options for your supplements for A and B. So, Mr. Hone, what would be the size of the supplement to a 50-degree angle?
I'm gonna guess because I'm not totally sure. But would it also be a 50-degree angle?
It would not. That'd be the vertical. So you're getting confused. I'm kind of introing both at the same time. But if we have to make a straight line, what's the measure of a straight angle? How many degrees?
180.
180. So I can draw a straight line pretty easily. But if I need to make this add up to 180, what would the size of that angle be? 130. And if you went the other direction, you could have a straight line coming this direction.
That's kind of what I made with like both arrows.
That would be 130. Then these two 130s are vertical with each other. These two 50s are vertical with each other. But this pair is supplementary, that pair is supplementary, that pair is supplementary, that pair is supplementary. Any pairs that add up to 180 are supplementary. So we've got a bunch of supplementary pairs there now. And in B, if I have 165, Mr. Tavella, what is the supplement to that?
That would be 15.
Yeah, 15 degrees. So this one's a little bit harder to draw. I can come here, and I can draw a little arrow into there and label that that would be 15 degrees. Or I could draw up here, and I can draw a little arrow in that that would be 15 degrees. So if I show both supplements, both adjacent supplements, I create a vertical angle pair. So supplements have to add to 180. You will notice in your homework, well hopefully you will notice, I switch back and forth between complementary and supplementary. So please read carefully. I'm not trying to get you in a trap, but I need you to be aware on those state assessments, it's not going to be in a nice pretty order. The questions will be randomly ordered. So you need to be really tuned in. Are we asking about a complementary pair? Are we asking about a supplementary pair? So please read carefully on this homework. Anyone done the 10-3, 10-4 yet? You see how it switches back and forth between, yeah. So the whole homework, it's not like complement, then supplement. The whole thing kind of goes back and forth. So try this got it. If you know the measure of ABC, and actually let's try to draw this out so we get familiar with that. So let's draw an angle that's approximately 48.4. So if I imagine, don't draw this yet. Just come up here with me for a second. Give me your eyes. This, we know, is a perfect 90-degree angle, right? A right angle is 90 degrees. Half of it would be 45. So if I'm trying to draw something that's approximately 48, I want it to look like that, but a little bit bigger and then I just label it, and I say, okay, that's 48.4. Then I also have to label the lettering. If this is angle ABC, where do I put my letters? Ellie, do you know?
I'm going to try. A would be the one that's the ray that's like reaching over, kind of.
It actually doesn't matter where A goes, but this is right. Like, you have a right option there.
B is the vertex.
That's the only thing that actually matters.
And then B could just go wherever.
So, A and C are switchable. It doesn't matter where they are. B, your middle term, must be the vertex. With 3-point notation, the middle term has to be the vertex. So then, find the measure of its supplement. And I'm going to go ahead and draw it. You don't have to draw it if you don't want to. You just need to do the math, but I like to have pictures to support. So Ashley, if we find the difference between what I have and what I need to make my straight line, what do I need? Oh, that's fine. Take a second. You guys can use calculators on this stuff too, because sometimes with decimals it gets a little weird. If you don't want to use a calculator, treat this for a moment as if it was 50. What if this was 50? How many more degrees would I need? Anybody? 130, right? So, it's not 50 though. I need 131 and then another 0.6. So this becomes 131.6 degrees. And I can name this if I want to. If it's adjacent, I could make it a D or any other letter that I want. But I could say that an adjacent supplement, DBA, is 131.6 degrees. Any questions? So essentially all we're doing in this chapter, or in this section, is making 180. That's it. This is why I said that once we hit geometry, we're going to speed way up. Because the fact that we've done all the algebra and that equation work, this should make sense in your brain. Because what we technically did here was say some unknown plus 48.4 equals 180, and then we solved it by subtracting on both sides. You don't technically have to set it up like this, but that's what you're actually doing. Whether you think about it or not, to solve this geometry, you're doing this algebra. Try to find the value of x on the back of your paper. This is where setting up an equation would be useful, or you're going to have to be able to manipulate it on your own. I advise you, set up an equation. It is the easier way to do it. So, if I was going to set this up as an equation, Acadia... you're hiding back there. You guys like that I took the shelves out back there?
Yes, it's
Yeah, so that's meant to be standing. So if anybody ever actually wants to stand, you're going to have to give up your spot. But right now, it's alright because Dom's over at the other option for standing. Yeah. So, Acadia, what would you set up?
Would you do 180 minus 50?
Yes, but I want to start way back at the beginning. You know me, I like to write out all the work. So, when you look at this, what is it in your brain that you automatically know from what you see? Yeah, and that this combined is 180. So what your brain is actually doing, and you're just like jumping steps, which is okay if you understand what you're doing. Your brain is setting up 2x plus 50 is 180. You immediately wanted to get rid of this section, so you subtracted 50. So that then tells you that the 2x angle that is left here is equal to what? 130. Sorry, all I heard was the 30 the first time. Then, how do I figure out x? Whitney?
Divide by 2.
Divide by 2. Divide by 2. Break it up. What's 100 divided by 2? 50. 30 divided by 2? Put them together. 65. That does not need a degree symbol because your degree symbol's over here. X is not an angle measure. X is a variable involved in the angle measure. So you already have your degree sign. You do not need to write it. Andrew? Sure. Let me capture this. Any questions on that one? What we did? Just setting up an algebraic equation and solving it using the skills that we know. Andrew, hit me with it, or do you want to come up?
Sure.
Have at it. This is really convenient. I should make people come to the board every day so that I remember to pass out papers.
I have a question.
Yeah.
Do verticals have to share the same?
Vertex?
Yeah.
Yes.
Okay.
They have to share the same vertex and the same 2 lines, which we're going to get to all those specific rules here in a minute. Jeremiah, put your last name on your papers. There are 2 of these. So, you want to talk through your process, Andrew?
Yeah. So I got rid of got rid of the addition, and then that came out to 1, which 6 equals 4x, and then I divided by the 4, and then I got 26.5 for x. Not equals. Or no, wait, yes.
So, a little hard to see because all the work is in the same color and he kind of squished it all in there. That's why I leave you guys open space over here. Some of you guys do really good at writing your work. Some of you guys don't care that much. So he first took away the 74, found out that 4x, the angle that is left over, or the supplement to the 74, is 106. We divide by 4, and is that 26.5?
Yeah.
I'm going to write that a little bit clearer.
Sorry.
You're fine. I'm used to the smartboard. You're not. I now write better on a vertical surface than I do on a horizontal surface. Because I do this more. Like, you guys are used to writing on paper, writing on your desks. I do this more. I write better like this, not even looking at what I'm writing, than I do like this. It's weird. Like, when I sign my name now, I don't even sign my name. I just squiggle. Like on the credit card readers, it doesn't matter what you write there. You can write like, "Hi, banker," and it doesn't matter. Yeah. So, here's a question. And actually, I'm going to make this or complementary. So these special angle pairs, can the supplementary angles involved in the pair or the complementary angles involved in the pair, can they be equal? Tom, what are you thinking?
Well, for the complementary or the supplementary, we just did yes, they could be, because they don't need to be connecting, right? Or is that one?
Well, them connecting wouldn't make a difference for whether or not they're
yeah,
equal.
Okay, that's true. Well,
So you're saying yes.
Because you would only have to get to 180, and 90 plus 90 is equal to 180.
So both, we'll just say both angles equal 90 degrees. So then what about for complementary? Monica?
45, 45.
Both would have to be 45.
Wait, could we get more answers though? Because you talked about how you can combine more than just 2 angles.
But for them to be like, so we normally are talking about a pair.
Okay.
So just like the easiest way and what we normally are talking about is a pair. Even if we talk about multiple angles, we then, like, imagine that we had something like this, and this might be kind of what you're thinking about, where this was equal to this was equal to this, but then what we would say was supplementary was this and these, but we look at them combined. Now we can say the green or the blue, the black, and this portion of the red are supplementary when we look at all three, but adjacent angles can be combined. So we really can make or unmake as many angles as we want. Because I could draw another line here and make another angle. I could draw a bunch of lines here and make a bunch more angles, and still if I look at the whole thing, it's still 180. So, but then I can go back and combine all of these and look at it as just one angle. I'm going to clear this because if people weren't listening, that would be really confusing. Question, Ellie.
Could you still add an angle if you threw a banana at it?
Probably. You most likely could.
What are you talking about?
Has that already made its way around school or something?
What are you talking
No,
about?
Ellie was there with me.
Oh, well, yeah. So, Jaslyn came in this morning. Flip over to 10.5 if you would. Jaslyn came in and she was like, being a really good student, said, hey, I have something I got to tell you. I didn't get my homework done. And I was like, okay, get it done later. And she was like, okay. She was confused that I didn't care. What do you expect out of me? Do you expect me to be mad and yell? She was like, I don't know. I thought you might throw a banana at me or something. I thought that was really, really funny because I eat bananas a lot. So, your friend claims to know all the angles.
No.
They're just like a genius.
Oh my.
So they're you.
And she looks at figure 1 and says, okay, well, all the angles are 90. If you look at figure 1, would you agree that all of those angles are 90?
Yes.
Jeremiah, what do you think?
I agree.
Sean, why? Do you agree that, would you agree also?
Yeah.
So we got 2 people that agree. How do we know? Sean, we haven't talked yet today, so that's why I shifted to you.
The box sort of represents it, and plus they're all vertical.
Well, so let's assume we don't know about vertical yet, because be careful saying they're all vertical, because that's not quite true. But you told us, so this is 90 degrees. What do we know about this vertical line? Don't think about vertical angles, but this line that we see here. Jeremiah?
It's straight.
It's straight. What do we know about straight lines?
They're 180 degrees.
They're 180 degrees. So if this is a straight line, then angle 4 has to then be 90. If angle 4 has to be 90,
Angle 3 has to be.
then angle 3 has to be 90. And if angle 3 has to be 90, what do we know about all the way around a circle? Like if I stand here and spin all the way around, it's 360. So then this has to be 90. Yay! So your friend was right. But now you throw a challenge at them. You're like, all right, Captain Jack, see if you can solve this.
Where?
Captain Jack's actually the name of my friend's parrot. Angle 1 is now 80. Ooh. So now, hold up. If angle 1, label this please. If angle 1 is 80 degrees, what do we know about the horizontal line here, Julian?
The one diagonal to is going to be the same.
So back up and listen to the question I'm asking. What do we know about this horizontal line?
180 degrees.
It's 180 degrees because it's a straight line. So we're gonna get to what you We're gonna get to what you said, but we want to prove it. So what does that make happen? And there's actually 2 different things it could make happen. But if we look at the horizontal, if that has to be 180, what else?
Number 2 is 100.
Number 2, angle 2 has to be 100. So label that, please.
Oh.
This is our proof of vertical angles. This is how the Pythagoras and those guys way back when proved mathematical concepts. That has to be true. Does anybody have any issues with that? Has to be true.
It's not 100. It's not 100.
It doesn't matter if it measures that. If you are given... No. This is a good thing to talk about. If you are given the measure of an angle, you cannot use a protractor. If you are told what the angle is, because computers don't always generate the images to look correct, and sometimes we just say, okay, imagine what if angle 1 was 30? Okay, we know it's not 30. It doesn't look like it. But what if it was? And then we do the math assuming that. So you can't use a protractor. if it's given you stuff on the paper. Now, if it doesn't give you anything and it tells you to measure it, then we use a protractor. But then, so Manasa, if angle 2 has to be 100, what else has to happen?
So basically, angle 3 has to be 80 because on that line the two sides have to be 180.
This line has to be straight, so this angle has to be 80. If angle 3 has to be 80,
So 4 has to be 100.
angle 4 has to be 100. And now we've shown that when two straight lines intersect, go through each other, vertical angles are formed by two intersecting lines. And if you want, you could put straight, but when we talk about lines, we assume that they're straight. Are opposite each other, and vertical angles are always equal. What's a really fancy mathematical word for equal?
Equivalent?
Equivalent is a little bit more fancy, but there's even better.
Solution? I don't know.
Congruent.
Congruent? Now you threw me off. It's congruent.
Oh.
So I want you guys to learn this new vocab word. Congruent means... Okay, good. Well, you didn't remember it.
Yeah.
So, congruent means exactly equal. And we use this... Hey, guys. We use this in geometry a lot more than we use the word equal. Because when we're talking about the size of things, we use the word congruent. So we're talking about the size of angle. So you could say equal, but congruent is a fancier, better way to say that. Any issues up to here? So 2 and 4, opposite each other, they are congruent. 1 and 3, opposite each other, they are congruent. So if we look down here at this spiderweb looking image, we need to identify some vertical angle pairs. And you have to be careful because the lines have to be straight all the way down the angles.
There's a lot of those. Oh no,
Be careful. Try this on your own for a minute. Try this on your own for a minute. I'm going to zoom in a tiny bit. Jaslyn, what are you thinking? Give me anything. I just want any piece of information that you've pulled out of this.
Well, I saw that 7, and the one across from it doesn't have a number. They're equal.
What do you mean across from it? So 7, I've got 7 right in here. It involves these two lines.
Oh, wait. Sorry, it's the line that. 8.
So 8 uses the same two lines. Are they opposite each other?
C.
Are they adjacent? Or sorry, are they sharing the same vertex?
Yeah.
Are they equal?
Yes.
So are they vertical?
C.
Yeah! Angle 7 and angle 8 are vertical with each other. They both use this line and this line, and they both share the same vertex. By sharing the same, they're not adjacent because they don't share a common side with each other. They share the same lines, but they don't share a side. So they're vertical. Now, here's the thing about vertical angles. They can't be adjacent. Vertical angles will never share a side. They share the same lines to make their sides. But if you look at angle 8 goes this way for its sides. Angle 7 goes this way for its sides. They do not share the same sides, but they share the same straight lines. Sean?
5 and 6.
5 and 6 also share the same straight lines, and their angles will be equal to each other. Noah, what else? Have confidence in yourself. What are you thinking? Just tell me what's in your brain right now. Do they share the same straight lines? So this is why you have a question in your voice, right? Are there more vertical angles? Numbered vertical angles. Let's look. One uses this line, which does not continue through, and this line, which does continue through, but it can't be vertical with 2 since this line didn't continue. There's like some missing line. I mean, it just doesn't keep going. So 1 and 2 are not vertical with each other. 3 and 4, if I look at 3, it uses this line, and that doesn't continue on. They have to both use the same lines. Neither of those are vertical. So my only vertical pairs here are 7, 8, and 5, 6. Ozzy?
No, but
Not numbered, though.
Oh, okay.
There are more, but they're not numbered.
But it says name the angle pairs that are vertical angles. It doesn't say like name them.
8 and 4.
Yes.
They have to share the same vertex.
They do.
8
It's just
and
one.
4? Are you talking about 4 and 3?
I'm talking about 8 and 4 because
That's the middle. Oh, dude.
I think he's trying to think of like a huge obtuse angle.
I think he's thinking about the middle point being the vertex.
yeah.
Well, then that wouldn't be angle 8. Angle 8 is right here. This angle formed in this section. 4 is this angle formed right here in this section.
Oh, I'm thinking of the middle.
Yeah, it's the angle in the corner. Now, if you look at, so let me capture this and clear it. If you, however, look at this angle, and this might be what Ozzy's thinking, this angle and this angle, those could be vertical because they use this line and this line, and they're equal with each other. But those aren't numbered. These have no numbers. 8 is actually out here, 4 is actually out here. So for numbered angles, it was just 7, 8, and 5, 6.
There's so many more because it's literally like this. There's a bunch of straight lines.
I agree, but for numbered angles, that's it. So now, especially you detectives, now you can name whatever angles you want. So now you're not stopped by numbered angles. You need to name them using 3-point angle notation. You need to use your 3-point angle notation. So, like, if I gave you angle, sure, ABC, list what is vertical to that. Whitney? RBW right here uses the same 2 lines. And guys, if you want to really remind your brain, you could grab a couple of highlighters and highlight. I use the green line and the yellow line. Now here's how we're going to start to notate this. If I draw the angle symbol, gravity works, like the little arc in the corner, and I put 1 tick on it. And I draw this little arc with 1 tick on it. What do you think that indicates? That they're equal. Now, they are vertical, but that's not what that indicates. It just shows that they're equal. So, RBW. Anyone have another pair? Moms?
Angle QBR.
QBR, right here. I'll label that with 2 little ticks.
And CBM.
And CBM. Now here's the struggle.
Oh, that's this.
This line
Then it
right
would be
here,
ABQ
Correct.
and MBW.
that line kinks. This is not a straight line because this goes off at a different angle than what this line goes down at. So those can't be vertical. This QBR doesn't have that straight line with it. So we're kind of restricted.
Another one would be AB.
Let's see if I can get this back. All right, another one. Sorry, Monica.
Okay, it's not actually because it involves.
Are there any other angle pairs that both involve two straight lines?
No.
So I've used my green line and my yellow line. Is QBM a straight line?
No.
No. Do I have any other straight lines?
No.
No. But there is another vertical pair here. Jeremiah?
CBM. I think. Pretty sure. No.
No, because that uses the not straight line. Other Jeremiah? That uses the not straight line. We can't use the not straight line.
Is this one of those things at the bottom?
Andrew?
It's ABH.
A,
R.
B,
That's
R
what I meant.
uses both straight lines.
I put ABH again.
So what angle would be vertical to that, Elena?
CBW.
C, B, W.
But there's more.
But there's more.
You could do CAB and WBR.
CAB is not an angle.
But wait, there's more.
They're trying to make a joke out of CBW.
No, so I don't care what jokes are trying to be made. Here's the critical thing you need to understand. The vertex has to be in the middle. A can't be your vertex. Somebody said CAB. A can't be a vertex. It's not a vertex. You said CAB.
I meant CB.
So, CBA is the same thing as ABC. They're the same. So you could write it differently, but it doesn't change what it is. So we've now used both vertical angle pairs. There's no other pairs. There's different ways to write what we've seen, but there's no other vertical pairs. So here's a question. Can vertical angles be supplementary? So what does it take to be vertical? Let's remind ourselves. What does it take to be vertical? Is that hand up or down? I can't tell. Andrew, is that hand up or down?
Yeah.
Okay, what's it take to be vertical?
It has to have a straight line and the two things share a vertex and they can't share the same line. Like they
Can't share a side.
not a side.
So-
that's what I meant.
Share two straight lines, share a vertex, and they're equal. Could supplementary angles do the same thing? Could they share two straight lines? Could they share a vertex? And could they be equal? What would they have to be in order to be equal?
No.
Both 90, right? We already talked about that. So if they both had to be 90, then let's draw a little picture. I know that that's 90. I know that these are all 90 actually. But if I look at this angle and this angle, they're congruent, right? They're equal.
Yeah.
Are they supplementary?
Yeah.
Are they vertical?
Yeah.
So yes, vertical angles can totally be supplementary if they're both 90. Hey, we're not done yet. I have like 4 minutes left. I don't know when we started thinking 45 was the end of class. It's not. It's 49.
I thought it was 48.
Well, it at least used to be 49. I think we chopped a minute off each class this year. But really, you guys don't need transition between class times since you can go to the bathroom during class and everything. You should be able to do all this homework. We're just going to bust through the last few problems here real quick. So, who can set up the equation that I want to use? Actually, let's try this. Julian, can you set up the equation that I want to use to solve for x here? So the first thing you have to ask yourself is, how are those values we've been given related to each other? Are they going to be equal? Are they going to add with each other? Are they like, they're equal. So what we want to set up here is the 4x plus 40 equal to the 140, because these angles are vertical to each other. What would we do first here then, Mr. Smith? Is out of the room. Mr. Hoover, what do we do first?
Subtract the 40.
Subtract the 40 from both sides. Colin's gone. Sean, what do we do next?
4x equals 100, and then you want to get rid of the 4, so you divide 4 on both sides.
And x equals 25. Any questions? We're not done. Got it. Now, hold on a second.
How does that
Try to solve this mentally. If you look at the 5x, if you have highlighters, which you should, my advice is that you would, my 5x uses this line, and it uses this line. Which means that the angle that would be vertical to it would be this. Can we figure out what that is?
Yes.
Anish, can you figure out what this angle is?
Yeah, like that angle is vertical, so it would also be 5x.
But it's also, I can't just relate 5x to 5x. That won't do any good. What else do I know? Forget about all this up here. What if I just showed you this?
So 90 degrees.
They're complementary, which means this has to be, as your classmate so rudely already said out loud, it's got to be 50, because it's got to add up to 90, and if 50 equals 5x, what does x have to be? 10. And now we can make that the end of class. Have a wonderful day, guys.
You too.
Thank you very much. I shall try.